We have with us today the technical manager for Europe, Middle East, and Africa region for Astronergy, Ibrahim Desouky. He's here to share with us today Astronergy's N7 module technology. Welcome to TaiyangNews, Ibrahim. You can please share your presentation now.
Can you give me the host to share my presentation, please?
Yeah.
Also, if you don't mind, just give me the accessibility to switch on the video. That's fine.
Raya, you can please help.
Can you just, share the, give me the accessibility to share the video? Okay. Now do you see my screen?
Yes, you need to get into the presentation mode.
Okay, that's perfect. So, first of all, thank you to the organizer and thank you for all the attendees that are already watching our presentation today. First of all, during today's presentation, we will be discussing 5 main topics. First of all, the company introduction. So here we will introduce some valuable information about our company in numbers, what are the achievements that were already done in the past few years. Then the second topic, since Astronergy is pumping huge investments in the R&D, so we gonna review together the latest technical upgrades that we already achieved on the cell side and the module side. After that, we will review together the latest release products that we already showcase in SNEC and interstellar exhibition. Plus, we will debrief about the excellency of our N7 series. We will show the technical advantages and the commercial advantages as well. Last but not least, we will explain what is our current production capacity and what is our strategic plan in the near future to expand our production capacity on the cell side and the module side. Here about we start. Actually, Astronergy is funded under Shint Group and corporate, and Shint has mainly more than 7 business units related to the power generation, power storage, transformations, distribution, trading, and consumption. For Shint, in order to contribute to a sustainable energy world and contribute to the net zero carbon world with solar power, Shint already funded Astronergy in 2008 to adopt the vertical integration business model to produce polysilicon silicon wafers on the upstream, and on the downstream, we are producing solar cells and PV modules. Here are our companies in numbers. Actually, the total revenues of last year for Shint was $18.34 billion, and we have more than 40K employees are belong to our company operating internationally in more than 140 countries. Moving to Astronergy, our revenues last year was around $3 billion, and we already top ranked as the top 6 PV modules shipments among all suppliers worldwide. Plus, our production capacity last year was 20 gigawatt, and in the upcoming slide, we will show you how we double our production capacity by the end of this year. Actually, toward the green energy, currently, Shint is owning more than 11 gigawatt solar power plants that contributed to carbon emission reduction of 8.3 million tons per year and generating more than 8.3 billion kilowatt hours per year. So moving to the technical upgrade, and actually here we are presenting the latest solar panel that we have in our products portfolio in 7. In this module, we already upgraded the cell technology and some features on the module side. So the first technical upgrade, we already changed the cell dimensions from the standard M10 182 times 182 length to 182 times 191. And in the upcoming slide, we will explain about the advantages of these cells dimension. Moreover, we are using the latest N-type TOPCon cell, the third version in all our products. Then we already upgrade the number of busbars from 11 busbars to be like 16 busbars. Plus, as you see on the down images, we have two main technology for the double class modules. Actually, we are using double glass on the front side with specific thicknesses for double glass and for the single glass. Plus, we are using also light redirecting film between the interspaces of the cells in order to capture solar irradiance as much as we can. So here are the advantages from moving from the N5 cell dimensions to the N7. Actually, the cell power already increased by 7.6%, and the wafer area already increased by 5%. And here's the advantages of the upgrade to 16 busbars. The micro cracks tolerance already increased. So thanks to 16 busbars, the module can withstand much more mechanical load. Moreover, the resistance inside the cell is lower than the 11 busbars, mean that the efficiency of the cell will be slightly higher. And so if a single opening crack forms between two busbars, the redundancy in the wiring allows the current to still be collected. Moving to the cell, the TOPCon technology, the latest version that we are using, and actually, thanks to the N+ poly heavily duped, causes energy band bending to achieve carrier selectivity. For example, attracting electrons from the bulk while reviling the holes. Also, thanks to the tunneling oxides, we are using a porous-thin layer within a range of thickness 1 up to 1.5 nanomicrons that allow measure carriers or electrons to pass through. Also, thanks to the passivated contacts, the metal contacts and the bulk are isolated by the N+ layers. So thanks to that, we maximize the contact recombination. So briefly, the main advantages of this version of a TOPCon cell: efficiency in the mass production is up to 25.6%. The efficiency in the R&D theoretically is 26%, and the bifaciality factor is 85%. Here is the anti-reflective coating. Actually, we are using two layers of glass in the front of the modules instead of the standard glass, traditional glass. So the advantage is here that the transparency is up to 0.3%, and the power increase up to 2 watts per module, plus the durability of the module already increased. This is really important technology since we already reduced the cell shading by 30%, the power already increased by 2%, and the specific energy yield increased by 0.5%. The main point here is that we already hardened the surface of the glass on the backside of the cell itself. So in this case, the surface will be more rough than the standard glass up there. So we can capture solar irradiance as much as we can. According to that, also the mechanical load already increased by 6%. Reviewing and showcase the latest products that we already introduced in Intersolar and in SNEC. The first module is the N578 cells with standard dimensions, and the maximum power output here is 630 watts, and the cells dimensions are the standard M10. Actually, we are using in all our modules TOPCon technologies, plus 16 bus bars as well. The efficiency of this module is 22.5%, and we are using also here the anti-reflective coating and LRF light redirecting film. Moving to the N7, as you see here, the dimension of the cell already changed from the traditional one to the length of the cell 191. We reached a power peak of 615 watts with efficiency 22.7%. Plus the N7 with zero pass bar, and this is really a new technology we are using in our modules. We already introduced these modules with power peak 585 and efficiency 21.6%. For the residential modules, M7S with dimension 1.8 meter height. The power peak of this module is 450 and the efficiency is 22%. N5S with 54 cells for the residential application as well. So the power peak here is 430 and the efficiency is 22%. We still using in this module the 11 bus bars, but it's under developing to upgrade to the 16 bus bars. Last but not least, since the demand in Europe already increased for the agri-voltaics module, we already released the latest product in the market N7 with 48 TOPCon cells. The power peak of this module is 385 with efficiency 14.9%. This is brief about our products portfolio. For the N7, the power peak is 615 watt with efficiency 22.7%. For the N7S for the residential, the power peak is 450 watt with efficiency 22%. And Astro on the right-hand side, N5 with 22.5%. Some others products N5 zero bus bar with efficiency 21.6%, and the smaller module for the residential N5S 22% efficiency. And the agrivoltaic module with efficiency 14.9% and transparency of 35%. Within this part, we will review together the technical advantages of the N7 series and the commercial side. First of all, here we are sharing the thermal performance of the N7 comparing with the PERC technology. Actually, the efficiency here is 22.7, temperature coefficient is 0.29% per degree Celsius, and the bifaciality is 18%. The working operating temperature of our module is within the range 0.5, 1.5 degrees Celsius. And all these simulations is based on our on-site testing facility in Haning in China. Here is we are showing the optical performance while we are using the light redirection film and the glass standard module. So the instance angle modifier that's measuring the optical loss. As you see here, the optical loss while using the light redirection film is slightly lower than the glass traditional glass. Here is comparing the electrical performance between the N7 and N5. Actually, as you see here, also while using the light redirecting film and comparing with the standard glass, the specific energy yield already increased by 0.5% energy yield. On the slide, we are comparing between the N7 and the PERC is significantly higher for the N7 because the energy yield already increased by 3.5%. On that slide, we would like to say that the N7 series already passed the reliability test. So as you see here, it can perform well after the first testing plus the third testing in row. So you can see that the drop of the performance is not that significant comparing the first one, second one, and the third one. Here we are reviewing the economic advantages, comparing the N7 with the N5, Astro N5. As you see here, you can save with the N5 almost 21.6 kilowatt comparing with the PERC technology, and it's highly great for the N7 since you can save almost 40 kilowatt. So the free saving is within the range 0.04 or half cent up to 1 cent per watt power. Also, there are some economic advantages showing the lifetime energy gain in several countries globally. So the average here for the energy gain is 2.8%. Goes to the Astro N7 compared with the technology 550. Here is also the balance of system already reduced by average 2.1% globally. Here, according to the balance of system reduction, the levelized cost of electricity already reduced by 2.5%. So how can we cover here the high demand of the market globally since we are expanding our business activities internationally? We are about to construct four factories in China in order to reach modules production capacity of 15 gigawatts and cells production capacity 45 gigawatt. The thing is here that 80% of these cells capacity will goes to the N-type TOPCon by 36 gigawatt production capacity for the TOPCon cells. And this production capacity will be increased over the year. Our target by 2025 to reach production capacity for the PV modules up to 100 gigawatts, and the TOPCon cells production capacity will be 81% with ratio 90% comparing with the PERC technology. In order to ensure that we can introduce high quality products to our clients, we already built up a laboratory, in-house laboratory in our factory in China, and this laboratory can perform up to 14 testing. So this facility already approved from national accreditations, third parties from CNAS, DUV, CTS, and Intertek. Beside this laboratory, we have on-site a testing facility in order to test the performances of the modules on the long run. So thank you for watching my presentation, and I'm open to clarify any questions from your side.
Thank you, Ibrahim. 100 gigawatt module capacity by 2025, quite impressive. I'll just quickly squeeze in a question here. So you spoke about your N7 today, but you also have other sizes. So do you plan to eventually move completely to N7 size, or you want to stick with other sizes as well?
Actually, it's still under discussion because we need to also evaluate the performance of the N7 and N5 on the long run. But for sure, if we found that the N7 has like upper performance on the N7, we will do like a delisting plan and promote on the N7. But this is not a short-term decision. We can talk about that like in the upcoming 2 years, let's say.
Thank you so much, Ibrahim. And may I request you to please stay back and join the conversation in the chat room. Probably there are some queries for you to answer there.
Thank you very much. Thank you.
Thank you.